Okay, hello, I'm Maxim. Um, Here's my Who Am I slides. Yep, that's me. I'm from Staten Island. Uh, Third year cybersecurity major and math minor. Still haven't declared it yet. I still got to do that. But like in spirit, I am. I'm an infrastructure engineer at FM. I'm actually on co-op right now. I'm supposed to be working right now, but I'm not clearly. But I'm cleared from my boss. Former Fed, obviously, as everybody knows. And I guess just my main tenants are basketball, jazz, food, plants, and cats. Maybe my girlfriend sometimes. She's pretty cool. And ops. I guess that's all I got for my what I do on club. I do a lot of other things. I planned a competition last fall. That took a lot of time. I was the RITSEC CA. I was red team, but like I haven't really done stuff for that in in a minute, so I don't really put it up here anymore. But I do a lot of things. I just wrote ops though. So, all right. So what are we going to talk about today? Is containerization. That's the topic of the education, but containerization by itself is really not much to talk about. You can talk about what containerization is, but what really we want to focus on is um, how we actually use it, right? So we're going to talk about virtualization containers, right? Get a good background on that. Then we're going to talk about the applications of it, and we're also going to talk about different container engines like Docker. Also, how are these containers used? Something like Kubernetes. And in the end, we're going to talk about container security. And yeah, so first, it's important to talk about what is virtualization. If you read this long and boring paragraph right here, it's something about abstraction, including virtual computer, hardware, storage devices, yeah, stuff like that. But that's kind of boring. So the TLDR on that is you put a computer on top of your computer, and it's not actually there, obviously, because you only have one computer, but there's a virtual computer on top of your computer. And that's virtualization. You are emulating, sometimes you're emulating storage, networking, display, etc. The purpose of virtualization is you virtualize only what you need to virtualize. So that's what we're going to be talking about today in terms of containers and virtual machines, how they're different and how they're similar. And on the topic of that, we'll talk about what a virtual machine is, because you don't want to get them confused with containers, right? Because they're very different. So a virtual machine is a computer system created using software on some physical computer, functionality and other stuff. Okay, yeah. So virtualization of a full computer on top of yours. So that includes BIOS, UEFI, TPM, and other top-level programs. So the entire operating system as a whole. When you think of your computer, right, you have not only do you have your operating system, you're running Windows, you're running Linux, Mac OS, but you also have device drivers, right? So how does your software interact with hardware? So like, you press the volume up button, it's going to use that device, all that hardware, device drivers. I don't know how hardware works. That's not really my thing, but someone else could explain it. But that's what the operating system does, right? You have your hardware. It's how it interacts with the hardware. You have device drivers and all that stuff, and that's what a virtual machine is. If you're to go into some kind of hypervisor, whether you're using like VMware, I'm going to use Proxmox as an example because that's what I'm most familiar with. You create a virtual machine and you have stuff like your display settings, right? And you have a long drop-down list of what you can select for display. You have, you select what your BIOS UEFI stuff is. You select other stuff, other hardware stuff, which obviously is not actually there, but it's going to emulate that, and the computer is going to be able to use that. Now, we can switch around and talk about what a container is. So the TLDR on that is it is a virtualization of software on top of part of your host operating system. So when we're talking about virtual machines, we think of emulating an entire operating system, emulating hardware and all that. A container does not do nearly as much as that. It doesn't need to, because what a container does, it is just essentially what you want to think of it is as like just an application, right? You created a web application and you containerize it, right? You're not saying I'm containerizing the whole operating system which contains that application. I'm just containerizing that application. And what that container is going to do is just a virtualization of just that software, right? Just what you need to run that web application. And it's just going to run on top of your host operating system. So what does that mean when you're virtualizing your software? So let's take Nginx as an example, right? It's just a standard web server. That's going to be like an example we use a few other times throughout this slides, but say you want to containerize your Nginx application, right? You have, what do you need? You need the Nginx binary, right? Whatever Nginx actually needs to run. You also have the config. You have your actual contents of your website, right? And you package that into what is called a container. Now everything is isolated in that container, and you have it all neat and packaged up into something you can, deploy elsewhere. You can move around, and is kind of, what is it? Agnostic? Is that the word? To like operating systems? Yeah. So it is kind of like you can use it anywhere. And here is just a little comparison, so you don't confuse them. But like I said, virtual machine virtualizes the entire operating system down to the software, which interfaces with the virtual hardware. And you also have a container, which is simply packaging as software and its dependencies. And you might be saying like, oh, Max, I've seen like a Ubuntu container. Like, is it like you're wrong? It's doing the operating system. It's not. I promise you, it's not. It's just taking whatever Ubuntu needs to run in that, like, it's very lightweight and only what it needs to run. So it'll have like that file system. It'll have some of its core utilities, but the operating system itself is not there. And now you're played as a fool because you think that there's an operating system, but it's not. It's just really good at making you think it does, depending on what you need it for. And here's just a good visualization of it, right? So with a virtual machine on the left, you have your infrastructure. It could be a server, it could be the cloud, or it can just be your computer, right? That's your infrastructure. You have a hypervisor on top of that. So on your laptop, maybe what you use for every day, that could be VMware, or it could be VirtualBox, right? That's your hypervisor. And within that hypervisor, you are emulating individual hosts or guest OSs, right? So this green one right here, that could be Ubuntu. This one could be Fedora. That could be Windows if you're virtualizing that for some reason. But what I want you to think about is that these are isolated and they are their own operating systems, right? They have nothing to do with the infrastructure itself. They virtualize their own kernel, their own hardware, all the device drivers that it needs, and it kind of has its own standalone thing. And now we compare that with what a container looks like, where you have your infrastructure, right? It's the same thing in your case, right? It's your laptop, cloud, servers. And your infrastructure obviously has its own operating system. So that's your, the Windows you use every day, Linux, Mac OS, whatever your operating system is. And then you have a container engine on top of that, which hosts containers, right? And now these containers are going to be using your operating system. When talking about container engines, that's going to be when we talk about Docker in the upcoming slides. But all of those containers are just using your host machine. It's using your operating system. It doesn't actually create any of its own, right? So that's really important to stress. And I got this from a really reliable source. If you want to think about it like this, one, build a fence around your application, the dog, so that the dog doesn't mess up your whole house. And that's a container. And then the other builds a whole new house for your dog to live in, and he can do whatever the hell he wants to do. And that's a virtual machine. So, when you think about containers of virtual machines, just think about the dog living in the house or in the fence. And so I mentioned container engines. A big one that comes to mind, which is kind of used all over the place, in big enterprise software, like down to whatever you use for your own hobby projects. Docker is like a really big container engine, which you probably hear a lot of today. And what is Docker? So Docker is a container orchestrating software that makes making, using, managing, and destroying containers sleepy mode, right? So if I were to tell you, like, okay, I want to containerize Nginx web server, I just want to do it right now, how do I do that, right? Like what actually makes a container a container? Docker is what does that for you, right? They have the Docker software, which runs on your local machine. They also have a registry of images for you to use, you know, both, what is it? Official images from like actual developers, right? So people who created, you know, certain Linux distributions like Ubuntu, for example, they'll upload an official Ubuntu container image to Docker Hub, and you can pull that from the registry. And when we're talking about container orchestrating software, there really is a lot that goes into it because, you know, not only do you have, you know, the Docker Hub registry, that's not really has anything to do with Docker itself. That's just kind of where you can pull images from. But you have, you know, the Docker which runs on your local machine. And we're going to be looking a little bit at how that actually works here. So Docker runs on a client-server model, right? You have a Docker daemon, which that is the service which runs. So for Windows and Mac, I believe they're both Docker engine, right? So if you ever use Docker on Windows or Mac, you would have to, before you do anything with Docker, you have to start the engine. And that's like the equivalent of starting the Docker D service on Linux. So that is the Docker server, and that's what's going to be handling requests from the client, which is the CLI that you're going to be using, right? So obviously we can't really talk about, you know, what commands we're actually going to be using because I haven't gone to that yet. But anytime you make a request through Docker, right, you run some kind of Docker command to either pull an image, to build an image, run an image, it's going to communicate via REST API to the Docker server daemon. And that's, like I said, your Docker engine. And what it's going to be doing is a lot of different things, right? So images, you can think of those as templates, right? So an image as by itself may not really do anything at all. So that's what you kind of call as templates, right? When you create something called a Docker file, you pull an initial image and then you do to that image whatever you need to, right? You copy files to where it needs to in the directories, all that stuff. And these containers, those can be programs. Like I said, there is an Nginx container you can use from Docker Hub, but there's also an Ubuntu container which you can use, which like what I said before, it kind of mimics an OS and, you know, kind of has whatever that OS needs to run in a very lightweight scale. And then you can also have, you know, just like any kind of program. So think of like a proxy, right? You can, there's such thing as like maybe like a caddy Docker image, right? You can pull that up, you can add whatever configuration you need, and that's that. There's also networks and volumes. So whenever you create some kind of Docker image or container, it's going to be creating what is called a bridge interface. So here I ran on just my own machine. I ran IPA, right, just to show my interface configurations. So right here you see my machine's like local IP address. This is how I access my machine. And right here you see Docker 0, right? That is the Docker bridge, which will actually communicate to the containers, right? The network is isolated. It doesn't have, you can see it doesn't have like 192.168.100.202, right? Because it's not using the same network. It's isolated within your local machine or wherever it's running. So what Docker is going to do is it's going to create its own subnet, which is this in this range right here, 172.17.0.0/16. And any container which is created is going to be on that Docker net. And it's only going to be exposing the port if you tell it to. So what's going to happen is if, say, you know, Nginx Nginx container, it receives a request on, you know, I want to contact this on port 8080, right? Your local machine is going to get that. The Docker engine is going to recognize, okay, I see this is meant for this container. What is this container's IP address? And now it's going to route through Docker engine to that IP address on that port. So that's how networks work. And then volumes. Volumes with containers can get a little complicated because containers are what are called ephemeral, right? When you stop them or you delete them, the data goes away, right? It's only what is contained in a runtime. I'll show you why that is later in the slides when we talk about container security. But for now, you have to understand that containers are ephemeral, and the way you establish volumes is by creating persistent volume storages, right? So on your local machine, you're going to have a persistent volume, which a Docker container can use. And you're essentially just going to be saying, okay, when I create this Docker container, it's going to mount onto that volume, and now it can use that volume. And if the container is stopped, or if it's deleted, as long as the volume is there, if it's being told to use that volume, it's going to have whatever it had before, right? So now, take a look at when you would deploy something without Docker versus with Docker, right? So without Docker, your traditional download the Nginx binary. Now you have to edit files on your system. So for content, it might be in var ww or user share ww, wherever you put it, which is decided by your etc nginx conf. So now you have to edit that to tell where to go. And then you have to start your service, right? That's how it usually works when you do it without containerization, just manually. And with Docker, there's many type of, there's many ways you can do it. How I had here, which is kind of similar, kind of the parallel to doing it manually, but automated, is you would write a Docker file, and I'll explain what that is later, but you write a Docker file which is just telling Docker how to put that image together. And then you're going to write the files on your system, which can be, anywhere, as long as the path to them is reachable by your Docker file. And that's going to be copied into the container, and then you build and run that container. And now, why is this so useful? So without Docker, that's a complete manual setup, as well as upgrades, right? So if you think about how that's going to look for Docker, you have in your Docker file, I should have put an example, but usually how it starts is with a statement that says from, and then the name of the image, right? So in this case, Nginx, Nginx version, I don't know what Nginx versions are, but all right, Nginx version 2.3, right? You have that established there, and when you build that Docker file, it's going to build based off of that version. Or you can have Nginx :latest, which is pull the most recent and updated image from Docker Hub or wherever your registry is set to collect from. And now that's important because, manual setup, it's not going to upgrade that version or do whatever until you actually, delete that binary or upgrade it. But with Docker, anytime you run that build, it will automatically pull what you're looking for and do that, right? So it's upgrades, and also manually, it's automated through actually getting that yourself, getting that for the program. It also automates versions, file paths, port commands. So like I said, versions of the programs or operating systems, file paths. So say you have wherever you have your Docker files defined, you have, www/ and then your HTML. And then you say, okay, I'm going to copy that from this directory into my Docker file, or into my Docker container where those directories actually need to be. So if you were to open up that Docker container and actually read the directories, you would see it kind of looks like a regular file system. In the root, you have etc, bin, all this stuff. And when you're using the Docker file, you would just tell it so that when you're building it, copy whatever I have here in the directory where I'm defining all my Docker configuration, and copy that into the Docker containers /etc /whatever or /var /whatever, right? So that's automated. And you also have commands, right? What commands do you run at startup? It could be, like I said, a container could be any kind of program. Maybe you want to run something automatically whenever you redo that binary, right? So manually, say you have to run, okay, I start my service, but now I always gotta run this command. With Docker, you can append to you have one command that you can run, which is just at the end when everything is set up, like what is it gonna run? So also without Docker, let's see, it's run completely by the host OS, right? So it's not isolated in the sense that containers are, where they have their own, we'll talk about that later with container security, but like I said, it is packaged nicely so that everything is running off of that container's relative file system. Inefficient packaging as well. Say you want to, you want to distribute your program, or you want to maybe move it to another host. How are you going to do that with manual? Okay, now I got to put everything back together, but all my configurations are like all over the place. I have something in Etsy, I have something in var, I have something in whoever, like wherever. With Docker, you put it all in one place, and it makes it easy to package and ship, right? You can package it together with build. Now you have an image with however you defined it, and you can host that on a registry, right? It doesn't even have to be Docker Hub. It can be something you host yourself. So you can host your own registry, and you can tell stuff to pull from that registry, or you can zip it up, as a tar, as a zip file, and you can just send it to another machine, and now you can just run that image. So it makes it really easy to package. And another thing you want to talk about with not containerizing your stuff or not using Docker is if it will actually work on another operating system. Because now all your configurations are set to use whatever you needed when you deployed that. So will it work on another OS? I don't know. Depends, maybe. Docker, it most likely will, because Docker's great, right? And you don't want to be this guy, right? So how do I use Docker? So this is just how to get started, right? First, obviously, you got to install it. I'm not going to walk you through that, but you guys can do that. I believe in you. You're smart. Just go online, Docker install for Windows, Docker install for Mac. So first, this is kind of doing it manually, so without the Docker file, but it's kind of the same thing, which is going to be running, not same thing running under the hood, but it's going to be doing the same kind of procedure, where you pull an image, and now you build it depending on how you want it. So if you're doing it as a command line, just for Nginx, right, Docker build with whatever parameters you need, right? Maybe that is doing it with a mount or copying files over to there. And then you run the image, right? So Docker run, and also you can specify some parameters, right? So a big one is Docker run TACP, and then whatever port you want to expose, right? So for Nginx, port 8080, expose that. Now the Docker container is listening on that port, and yeah, that's all you need to get started. It's really easy, and that's just the manual way to do it, right? You can do it like with Docker files, like I said, to automate it, and you could also do it using Docker Compose, like you see here, which doesn't even have to be for server use. I don't know why that's there. This is just the slide from last year, but for server use, Docker Compose is for using multi-container services, right? So compose like you're a composer, or really like a conductor, I'd say, because you have a lot of things going at the same time, and you want it to be, synchronized. Thank you, Chase. You want it to be synchronized, right? So maybe you have a web server, but you also have a SQL server, which that web server is going to depend on, right? You define a Docker Compose file, which says these are my services. This is what the web server depends on. And now Docker Compose up. Everything's going to go up in efficiently and gracefully. The web server is not going to start and be like, where's the server? Where's the server? I'm going to freak out. I'm just going to stop and not do anything, right? It's going to start the SQL server. Web server is going to reach out to it, and it's going to be like, okay, cool, it works. So Docker Compose pull, Docker Compose build, those are how you interface with that to pull those images, and also to build based off of a, typically it's a Docker Compose YAML file. So if you're unfamiliar with YAML, it's just kind of how you establish configurations, or kind of define, like, I don't want to say key and value, but that's kind of how it is, right? You have service, what's your service, web, and then you have all that data for there. Obviously, Docker Compose has like a lot of different things you can do with it. So if you want to actually see what are the different things you can do with it, I would highly recommend looking at the documentation, seeing what are the different options you can do, what you can do with these containers. And this is an actual quote which happened. I remember he said this. So that's Docker, right? That's our container engine. But we also want to talk about Kubernetes, right? Kubernetes, really cool, really complicated, kind of tough to work with, but it's really cool with some of the stuff you can do with it. So, for example, the CTF, which is coming up on the 21st, which shout out CTF, go sign up for that if you haven't already. That's running entirely on Kubernetes, right? As the person in charge for that infra, I set up that Kubernetes stuff, and I can tell you, like, some of the stuff that it does is just really cool, and hopefully I can convey that to you here. But what is Kubernetes? If you're unfamiliar, really its whole goal is to take containerized workloads to another level, and that's essentially what it does. Like, you have containerized projects you want to deploy, and Kubernetes just adds a lot of advanced and extensive features on top of that, so it makes it as efficient as possible, right? So what are the things it does? It does load balancing. So it'll receive a request, and it's trying to find which node to send it to. Which actually, you know what? I think I should show you this first, right? So this is how the Kubernetes architecture works, where you have n worker nodes and however many control plane master nodes, right? So control plane, kind of in the name, it controls the worker nodes, what's going to be sent to them, how jobs are scheduled, and then you have your worker nodes, which are actually doing the work, right? So you have what are called pods, right? Pods are kind of your individual applications, right? And within each pod, so I'm going to show you an example. You have like a CTFD pod, right? Here, let me show you. Right, this is from the actual console of our Kubernetes deployment that CTFD is going to be running on. These are individual pods, right? We have 3 pods to make CTFD actually run. You have CTFD, like the site itself, how that website actually runs. You have our Redis server and MariaDB, right? So that you can, because it has to actually handle, people who register, right? So it has to do like identity management. It has to handle storing challenges and the volumes that the challenges need, right? Because we're going to be hosting a variety of different challenges. Not all of them, you just download a thing, right? Some of them are going to be hosting an individual like web server, which people are going to actually have to target, right? So that takes a lot of, it'll have some storage that it needs to communicate to, but this is what we call like management, right? That's because it's managing CTFD as a whole. It doesn't actually have to do anything with the challenges. And these are the individual pods. And if you reference this, you can see that each pod has however many containers, right? So maybe one will have 1 container, another will have 3. But if you look at this on the right-hand side, you can see that CTFD has 3 different pods, which just look like CTFD and then some gibberish value, right? I'm sure that is actually computed somehow. It's like a hash tag, whatever. But what you want to understand is that these are 3 different containers doing essentially the same exact thing. And what it helps with is, now you can maximize your uptime because you have 3 different things in case one fails, right? So CTFD, it dies, right? This one dies, but now there's still another 2. And now those are running. You can look at the logs, you can do whatever, and you can fix it. And it's really cool with how you can fix stuff in Kubernetes, because if you see here, you have something called etcd that stores a key and value of how you want the system to look, right? So I'm not sure how it looks under the hood for something like this, where you have pods running, but it has, etcd is somewhere in the control plane, and it says, okay, for this pod, I have a certain way I want it to look, right? That could be resource usage, it could be number of pods, or just other health checks. And if you do something like delete all the pods, it'll just spin them right back up. And that's why Kubernetes is what you call self-healing. And that third bullet there is because it has a value of what it wants everything to look like, and it'll restore it to that manner, right? And because you're doing it with containerized workloads, those are really like, it's kind of like lightning fast, right? Because you're not doing anything with the OS, you're just doing whatever it needs to run. And in this case, the worker nodes is, what we were talking about, your infrastructure, which is hosting those containers. And in many cases, I believe for OKD, which is our Kubernetes thing, it's Docker is the container engine. So Docker is actually, orchestrating these containers within these pods. And yeah, what else? So we have the controller manager, which kind of decides how to distribute things, right? So you're talking about load balancing. It has to decide what's the best course of action to distribute workloads. And what else can we say about it? Storage orchestration, it kind of does stuff similarly to how you would establish volumes for Docker, right? So these containers need a volume to, right? You destroy the pod, and now you have new containers, but where are those containers going to be getting their storage? Same thing as Docker. You establish a persistent volume, and now whenever those containers wake up again, they're using the same configuration when they start up. They're going to attach that volume, and now they have a volume to work with. And it's like you're picking up where you left off, right? Because everything is added to that volume, and when containers restarted, all it really has to access is that data. Also is just centralized management, right? You have, web server, database, Redis, and you can have separate Docker containers for everything and just kind of maintain it through like Docker CLI. Like there's like Docker PS, which lists Docker running instances. Or you can do it like this where you have, a really nice web GUI. You can see everything. It's way better visualized. Everything is like contained well, and it's like similar declarations, right? So you have similar ways you establish deployments and all that stuff. And then this is just looking into one of those containers, right? One of those pods. So you can see here, this is the worker that it's running off of. It has a pod IP because it establishes its own network for pods to be able to interact with each other, right? So CTFD has to send data to Redis or MariaDB, and it's going to do that through the pod network, right? Everything is isolated. You also have, I think, somewhere defined. Oh yeah, so right here, volumes. These are your mount paths because they're containers. They're ephemeral. Every time they start, you want them to use the same mount paths. And what else? I think you could see replica. Okay, well, somewhere is defined the replicas which you want, and that is defined as 3, which is why there's 3 of them running. You could also see the image which is using. So image registry. This is the actual container which you have pulled, right? So we were talking about before, you pull an Nginx container. In this case, you're pulling a CTFD container, which has all the dependencies which CTFD needs to run, right? You don't have to do it manually. Someone pushed it up there, where we get it, I actually have no idea. I forgot. But it's there, and it works. So that's all I care about. So that's a lot about Kubernetes. It's really great because, I mean, there's a lot of stuff you can do with it. It makes stuff really available because it's self-healing. Load balancing, if you're, enterprise software and you need to be able to handle a lot of requests. You could also do something with, like what we do with OKD is we have one service which runs that the controller node, whenever it recognizes a new route, so say you want to access CTFD, we establish the route, ctfd.ritsec.cloud, right, or .club. That route, obviously, we just created it. It won't have a valid certificate, but the control plane can recognize, oh, I have a new one. I'm going to run my Let's Encrypt process, use like all like the Acme protocol to automatically generate a certificate and give it to that route. And now you just have a container with a valid cert, and you really didn't have to do anything except for add like a line to the configuration, right? With previously, if you're doing it manually, you have to like do all this stuff with, you know, configure Let's Encrypt yourself, put the certificates in the right place, all that. But now it just does it automatically because it has a set key value, like how I want everything to look. It recognizes, okay, I want this to have a valid certificate, so I'm going to run my Let's Encrypt process and get that certificate for it. And now we can talk about some more fun stuff. This is pretty cool, right? Container security. So containers run as processes. And you might just say, okay, cool, I don't care. But it's actually pretty interesting, some of the stuff you can do with it, right? So if we run ps aux, which many of you might be familiar with, just kind of lists every process in like BSD format. It's listing every process, and I just tailed the last 10 because this is the one which started most recently, so it'd be at the bottom. And we have this forest parameter, right? What that does is it shows you the entire tree of processes and where they spawn from and what those processes are attached to, right? So we have our worker process, right? That's doing the actual work. As for what it's doing, you know, that's pretty going a little deep, but that's the worker process. That's what actually is handling all your Nginx data. It's handling requests, all that fun stuff. And you have your master process, you know, somewhere along the line it decided, okay, I need to spawn these 2 worker processes, and this is how it's going to run. And those are all a part of this program right here, containerd shim run cv2. So this is a part of containerd used by Docker to manage containerized apps. So this kind of gives you an idea of what Docker is doing under the hood, right? Containerd is the Docker runtime. That's what is like actually managing all your containers. You know, every time you get a request, it's going to handle that. So Docker pull, build, containerd is running all of that. And what a shim process is, if I remember correctly, it's just kind of an intermediary between software, right? So it's taking a request, it's doing whatever it's designed to do, and then it's spitting it out there, right? So you can see that our entire Nginx program, or you know, Nginx, it could be Ubuntu as well. Your entire Ubuntu program is just spawned from this one containerd instance. And we're going to go a little more in depth here. So because it's a process, you can see, So here, take note of this process ID, 18348. And this is what we can do with it. So proc in Linux it's one of the root directories, one of the directories as part of the root directory. And it's not really like a directory the same as etc is. It is dynamically updated with data from running systems. So in our case, it's updated with data from the running container, and it's put in the same process ID. That's the name of the directory, right? So you cd into proc, you cd into the same number of process, the PID, which is 18348. And from here, you can, there's going to be a few different directories, right? That's what the process is actually going to use. But you can ls, one of the directories is root, and now you have the file system of the Docker container, right? And we didn't use any Docker commands to actually access that file system, right? The only thing we did was find the Docker instance, the running process, see what its master process is, and find that process in the /proc directory and list that directory. And now we have the entire file system. And that's not just, you can do more than just list, right? You can add data there, because if you have the right permissions, it's not, obviously you can run it as root, but this is running with some kind of user, and if you get those right permissions, you can actually just add data to that running Docker container without actually having to use Docker at all, right? So that's just finding the root directory. You could also, there's a bunch of things you can do. One of the important ones is this file name right here. That's going to be in the process directory. That's going to list environment variables. So right now, I mean, this is not very helpful, right, for our Nginx instance. That's just saying run Nginx with global configurations and don't daemonize it. So run it in the foreground. This is how Docker does it. But sometimes, you know, what can you have in environment variables? You can have an API key. You can have passwords which are being passed to the programs, right? So now we are able to read those environment variables also without ever actually touching Docker. And another thing which just kind of strengthens Docker security, which, I mean, this is not even just Docker, this is just Linux programs in general, is namespaces, which a namespace contains a process view from the, contains a process and kind of shields it from accessing anything else outside of that namespace, right? So we're using this ns-enter command here, which is just saying enter this process using the namespace which it is associated as. And this process can have a few different namespaces, right? So I don't think I listed it here. No, I didn't, but you can do sudo lsns, and you would see Nginx processes using a few different namespaces, right? So this is the process namespace. This is the mount namespace. This is the IP namespace. And you can see, right? So we enter that same process, 18348, and you list the mounts. And those are all the mounts that are accessible to the Docker container, right? But obviously, if we were to list the mounts from the host, right, not just from that process's namespace, you would see the mounts which you typically see in your Linux system, right? Mount is here to the root file system, all this other stuff that Linux does. Another thing is this process namespace. You can check, this is not the Nginx server, this is just a BusyBox container which I started, and then I just ran top. So that's running as a process, and then you enter that namespace and it's running the process. And now it just sees, okay, I have really one process, another process is the one we just ran, but that's the only process which it detects, right? Because it's running as a process, this is how Linux namespaces work. They contain these processes, and because containers are just processes, the same thing applies as if you were doing, you know, any other application which Linux uses. And another one is IP address, right? You enter that namespace and you run IP adder. And what is it going to get? This is what you would typically see as your main interface. And right here, you can see is that Docker net, which I talked about earlier, that 172.17.0.0/16. That's showing its IP address. But obviously, it doesn't show the host IP address. Same thing with namespaces. And there's a lot more you can do with namespaces. So one big one, which I didn't include here because I was still kind of learning on it. I didn't really want to include it if I didn't really fully understand it. But, you know, I'll talk about it just because. So there's something called C groups, which establish rules for what resources your container or process is allowed to actually consume, right? So when you're thinking about a namespace C group, you have my Nginx container. It has a specific namespace C group, and I'm going to look at the C groups, and what is it going to show me? It's going to show me what that container is actually able to use. So if that container is able to use a different namespace, you know, escape into, say, the host namespace, then it's going to say, oh, wow, I can use all these resources which the host is able to use, right? And it can just go crazy, right? So that's another kind of a nuance you want to think about with containers. When I explain that they're isolated and isolated from the rest of the system, this is what I mean. Namespaces and C groups, that's established through here. runc is the lower level runtime which containerd uses to actually establish those namespaces and C groups. Like how it does it is kind of, that's like above my pay grade. I don't know. But runc is what establishes the namespaces and C groups and what actually achieves that isolation, which we talk about with containers, right? It's not just, oh, it has its own file system. It has its own view of its IP address, its own view of mounts, its own view of processes. So it can't really play around with other stuff unless you find a way to bypass that, right? Change the namespace to, the hosts or maybe another containers, which is allowed to use more. So that's why we call it isolated. It's really interesting stuff. And yeah, I mean, I was gonna say live demo, but I can't. There's also not much time left, right? So here's things for you to try. Also, this is from the last year's slides, so this was just kind of left over. Obviously, you do the demos. Why wouldn't you? What do you get, like $1,000 if you get first place at the end, right? Yeah, it's like it's money, right? Oh, actually? Oh, I was joking. Oh my God. Oh, I was completely joking. Yeah. Oh, you don't have to actually like. Yeah. Yeah. No, I was just making a joke, but sure, that's yeah, that's awesome. But yeah, do the demos. Containerization is really cool. You're gonna be using it like all the time. Like no one does things manually anymore. Like, no one. Well, that's a bold statement, but if you do things efficiently, you're really containerizing a lot. It's really important for if you're going to be doing cybersecurity, infrastructure engineering like I do, like DevOps, or software engineering, you have to understand this stuff. You have to understand why it's good because everything just works so much better when you are doing it efficiently. And any questions for me? Yes.
What are the most containers that you've deployed at once?
So the question was, what are the most containers that I've deployed at once? I guess it's cheating if I say the stuff I've done at work because they use a lot of containers. But I mean, Drew, doesn't like OpenStack do like a lot of it is just it's just like all containers. OpenStack, like the stack you use, the stack that just like breaks all the time, it's all containers. And like what containers are they actually running? Well, but like what are the images?
So it's actually a little more complicated. So OpenStack uses like a bunch of different things like Neutron and Nova and Cinder and like all these things.
Oh, sorry. Hold on. Wait.
Oh, the mic.
Yeah.
There's a bunch of things that go into OpenStack. Cinder does like volumes and Glance does images and Nova does compute and stuff like that. So when you actually run the Ansible, which is called Cola, you can look that up, Cola Ansible. When you run that, it actually deploys all the containers to all of the servers that we have that we call Novas, and to our storage nodes and our management nodes. And yeah, everything through OpenStack is just a container. It's kind of crazy.
Yeah. So I mean, I haven't done that personally because I'm terrified of the stack. It is a really scary place. But I've seen it happen, and I'm like, damn, that's a lot of stuff I really don't understand. And it's just kind of some like what is it? OpenShift? No, I'm losing my mind. Red Hat, like the people who actually create that, they kind of make the instructions for that, and then you just kind of run it for the most part, and those containers like build themselves. So it's a lot of stuff. If you like go into it, actually, you're like sure to lose your mind. But yeah, that's probably it. Yes, Drew. Oh
If
God.
you had to deploy
Oh,
maybe
Jesus.
resumes at a career fair or something like that,
Yeah.
what would be the best tool to keep your resumes in?
I would say probably RITSEC Padfolio.
RITSEC Padfolio. Presentation.
Wow, so impressive. Good job, Maxim. Good job. Thank you. Thank you very much.